Recording in progress.
And now directly for teachers. Present. Finishing. Under 2:30. Makes you seem disappointed. Oh, okay. 3-minute mark is fast. Oh, 145. 145. That's just I think they burned the paper. It was so fast. Teacher activity 130 on the board. That's drawing the circle and all the lines too. Looks like, are we finished? Nice, you're all beating the 5-minute mark. Okay. Most of you pushing on the 4-minute mark. Ella, I'm gonna have you join up for today. Can we take a moment to discuss what's the point of the unit circle? Okay, so what's the point of knowing the unit circle? Kyson, what do you think? Are we good? Are we good with that? From any point of the unit circle? Exactly. These are the kind of standard positions. Is it only sine, cosine, and tangent? And the reciprocal, so all 6. Of course, the quickest ones are tangent and cosecant. No, the quickest ones to find are sine and cosine. So I just like for you to do a little exercise right now with your partner. I'm modeling. So one of you will put your paper down, the other one will look at your paper. You may want to check one of those papers to make sure your papers are before you do this. But it's after like, okay, what's the cosine of 7 pi over 6? What's the sine of 3 pi over 2? Kind of go around. And you can get different, instead of calling this pi over 6, you can call this negative 11 pi over 6. While the other person is just thinking about it. So, let's see, does that make sense? Okay, so let's have the person on the left put the papers down. But check it first. When everything looks like it's right, the person on the left will put their papers down. The person on the right will let's, how many questions do we have? How about 3 and then switch 3 and then do it one more time? 3 and 3 to follow 6. Just sine and cosine. Just sine and cosine. Oh, degree or radian.
Yeah. I think, yeah. Well, five minutes. Hey. Wait, oh, 9. What's wait, not ready. Right. Oh, okay. Oh, that's
Just another 20 seconds or so. Last question. Okay. Fine. How'd it go? How was it getting the answers from your head? Did it work out? Oh, yeah, but you figured it out. Okay, good. Sweet. Let's just kind of refresh ourselves where we are in the units. I think I told you we're having a test on the 17th. Is that right? That is incorrect. It's more of a quest. Like it's not a full test. So it's like kind of a big quiz, small test. So it's impact on your grade wise, it's less pressure than the other ones, just so you know. Because it's such a small unit. And really what's going on here is this naturally fits on the unit that was before break. But we had to give you a test before break. So this is kind of splintered off from what would have been on the test. So it's still chapter 5. But we're just putting it as a separate mini unit. Okay, let's get through today because yesterday there was a question about phase shift and we hadn't introduced that, and today it's being introduced. Phase shift, I think I mentioned yesterday, is the same thing as a horizontal. That's it. It's the exact same thing. So you can see here, you could take that sine wave and move it how far? Pi to the right. Okay, so I'll mark that pi there. The period is still 2 pi. So I think I could do this. Does that make sense to mark that? Yes. If we have something like negative x plus pi, I think that's what you mean.
Well, I that and then but I don't know where.
And this just comes down to like something like y equals x minus 3 squared minus 1. It's definitely 3 to the right and definitely 1 down. So I'm not sure. Maybe I was talking about something else. Because it really is just that in that argument, if you see x minus something, it's gonna be whatever that thing is to the right. Maybe you're thinking, I'm not sure what that's referencing. But this is just shifting to the right. It's a phase shift of pi units, horizontal phase shift to the right. Well, horizontal phase shift is always to the right, so this is a horizontal shift, word translation to the right, or phase shift of pi units. Yes, Katie. Oh, we should have all. You're right. We should have. I'm being a little bit lazy here. You're right. So this is 2 pi right there. This is what's in between pi and 2 pi? Pi and 2 pi. It's 3 pi over 2, is that right? Putting a circle, you know that in between pi and 2 pi is 3 pi over 2. And then between 2 pi and 3 pi, 5 pi over 2. If you want to, you could just count to here. So we have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, etc. It's asking for the domain and range, amplitude, period. Do we need to go over that, or are you okay? Any questions? As long as your x and y axes are labeled. with all of those values, I'm okay. In this case, for number two, we see that the amplitude is. You say 8? Yeah, the amplitude is 2, and the phase shift is pi over 2. Want to do that one, or should we skip it? Yeah, maybe. Nice. Yeah, there are multiple ways to express the same function. Kind of interesting to find this order. Good point. Yeah, so actually let's do this one. We have pi over 2 over here to the right. I try to do a good job about being even here. So all of these are my pi over 2s. 1, 2, 3, pi. Let's see, 2 pi plus pi over 2. What is that? 5 pi over 2. That's how far I'm going. My normal graph. Would look something like this. If I were to continue going backwards. You can see that this is very negative cosine. Does that make sense that this could also be represented by negative cosine without a phase shift? -2 cosine, of course. So either way. Thank you, Mamie. Three is a cosine that shifted to the left. I don't want to do that. 4 is a cosine that has been flipped over that x-axis and shifted to the right. So I don't want to belabor the points. I really want to just make sure you could do these. Go ahead and do 6, please. Do you have it? What's the first thing I should mark on the x-axis? What do you think? 0? 5 pi over 3. Make sure your neighbor is doing okay with this one. Check with your neighbor first. Make sure everything's going okay. How's it going? Katie, you have a question? Period five. Who said the period five pi over three? I did. Maybe I said the period ends at five pi. Okay, I'm gonna answer that in just a minute. Okay. I did? This one? That's it. I see. No, that's okay. Oh, no, it's, I went backwards, so this is our normal, our fundamental period right there. There's the sine wave. Cut into four pieces. I just traveled backwards. Yeah. Thank you. Good point. Yeah, because it moved over, so now we have to make that. So let's go over this very specifically about how to do this. We're beginning at pi over three and ending at where that 7 pi over three come from? Well, it normally ends at 2 pi and then we add pi over three. Does that make sense? So that's 7 pi over three. And I know I'm gonna break this into how many parts? Break it into 4 parts with 5 labels, of course. So break this in the middle, and in the middle. And it is important for you to be able to label all of these. So it's normally, if you look at the unit circle, these are the points: 0, pi over 2, pi, and 3 pi over 2, aren't they? But that's where we always do it. But all of these, we're going to have to add pi over 3, right, David? But then 0, we add pi over 3 and pi over 3. At pi over 2, we add pi over 3, completely executive. Pi over 6. Does that make sense? Visually speaking, it's actually kind of nice to do it that way. You add up pi over 3, which is like 60 degrees. Pi. Or you just definitely. That means that the second tick mark is now 5 pi over 6. What used to be pi has now been added with pi over 3 again. 4 pi over 3. Are we sure it's 4 pi over 3? Hopefully you're comfortable with your unit circle enough to say, yeah, I know that's 4 pi over 3. And the last one, you get 3 pi before the next. This subdivision, it's normally 3 pi over 3. You add pi over 3 to that, you get 11 pi over 6. Now you could do that. You know, if you don't 11 pi over 6. If you want, you could take your 3 pi over 2 and add pi over 3 to it. You could do it that way. I think it's really pleasant to do it visually. We know what pi over 3 is. You know that. We could add to any one of these and go through how many plates. Does that help? Does this match what you have already? Cool. If not, I make sure to connect the dots as needed. The last one, I think, what was unfortunate here is just everything looks so different. Right there. Not to do the same as all stuff. It's very easy to go back. I don't think that's the case right now for this one at number 6. But we do know that the amplitude is 1/2. So how many points do I need to graph this? I need 5 points, always 5 points. Starts off, what kind of axis is that called in the middle? I don't think I ever called that the midline. Sinusoidal axis. It is also called the midline. So is it a V? It is not a V. So this is what I'm looking for. This and this. Yeah, this one's cosine. Any question? Yeah, I'm gonna ask you to do one more. I'm gonna change number 5 to say something else. I say y equals -3 sine of 2x minus pi over 3. So before you graph this, would you please discuss what's happening with this sine wave? Okay. I want to hear, or I want to see, what does this negative do? Show me, what does it do? The negative flips it over the x-axis, the 3, of course. The vertical stretch, changing the what specifically of the sign? The amplitude of the sign, right? It changes the y value, it's the stretch of the y value, but specifically it's an amplitude of 3, right, Bailey? And then this 2, would you please show me what that's going to do? It's going to compress it such that the period is smaller specifically. Instead of 2 pi, it's going to be pi. And this shifted to the right by how much? That is a trick. It's not pi over 3. Dun, dun, dun. Because it's what? Because it's not clear what's happening to the x. Right now it's 2x minus pi over 3. Where did that pi over 6 come from? To make it clear, my recommendation is to take that 2 and factor it out. And if you do that, this becomes x minus what? Check with the neighbor. What has to go there for these to be equivalent statements? What is it? 5 or 6? Do we agree that that's equivalent to what we started with? So that's that basic was kind of hidden. That basic is actually 5 or 6. One for the right.
Then when we factor it out, like, we can like drop the 2 and we get
Yeah.
right.
It's a right of 5 or 6. But remember the period is, well, the period is pi, so it's going to end at 7 pi over 6.
I thought we had.
The period is still high, but everything is still.
So we have, you divide first, or multiply by one.
Yeah.
That, we divide
Yeah,
first.
multiplication comes before the addition. So the period in here, please make sure to label all 3 points inside.
Why did I do it? I was like, I'm a very good I just started to go right now.
Did you get them?
But it's actually not. I don't understand. I mean, no. I think it's hold on. I think, no, hold on.
Is this working out? Actually, it's not meant to be.
No, I know, I get it. Then I got out.
Okay. So let's talk about this. At the very least, if you can't figure out these numbers and you can just figure out that pi over 3, you can still graph it, can't you? I still want to see the 5 points. I still want to see 1, 2, 3, 4, 5. I still want to see this. But when it says to label the points, I either need to see coordinates or I need to see your axes clearly labeled. So we have the 3, -3, we have the beginning, hopefully we have the end. But those middle points are getting more and more difficult. Who'd like to give us an insight about how they did it? What'd you do? Any of these middle, I'm gonna label these for now, 1, 2, and 3. Do you want to talk about any of these? Which one? I'd love to hear kind of how you thought about this. Okay. 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 Oh, nice. So as which one are you doing first? I'm sorry. I see pi over four. So this one first. Okay, so pi over four plus pi over six. Okay. Are we good with this? Nice. Okay.
Yeah, and then I just added another. So I got the five.
You added another three pi over 12. So we had five pi over 12, and you added. Does this make sense to add three pi over 12? I love this. Because 2 pi over 12 is the same thing as pi over 4, and that's normal. You get with pi, pi 4, pi over 4.
I thought we're gonna go back. So.
We are, but we're starting here and then adding that pi over 4. Good question. I think that's the first one that you did. I thought this is pi over 4, pi over 4. So that's the next one is pi over 2. I'm sorry, it's gonna be this one. Plus. Pi over 2. Is that right? Wait, is it adding pi over 6? Yep, adding pi over 4. Okay. So you're adding the increment. Yeah, so 3 pi over 12. Nice. 8 pi over. Wait, so 7 pi over 12, you're adding. Oh, 7 plus 5 plus 3 is 8 is what you're trying to tell me. Okay. So that gives us 2 pi over 3. 4, oh, which I think still simplifies. Okay. But maybe it's better not to simplify yet anyway. Okay. 2 pi over. So you're adding another pi over 4 or 3 pi over 12. So 11 pi over 12. Okay. That was nice. Well done. What's that? Your mind. Nice. Any questions? Did anyone do this differently? That they'd like to share? Another way you may want to consider is by finding coordinates of midpoints. Do you know how to find the coordinate of a midpoint? Find the average. Yeah, so I may find this one first. Like this plus this is 86. Divide that by 2 almost like 1.5, you get 5. And then you do the same thing because everything's in the middle. I'm afraid there's no easy way to do this, but if you analyze and if you're okay with your fractions, you should be able to come up with some good numbers. Yeah. Whew, that was a lot. Let me give you a moment. It's now 10:10. So 10:13 to either decompress or discuss, ask me questions.